here. Okay. All right, so the sum of the length of any two sides of a triangle is greater than the third side. Any two sides have to be bigger than the third. Remember, if it's the same, how's it going to make a triangle? It's not. Okay? So, you have to check every two sides. 3 and 7, is that bigger than 8?
Yeah.
Is 3 and 8 bigger than 7? Is 8 and 7 bigger than 3?
Yeah.
Okay. So, let me write that. 3 plus 7 is bigger than 8. 7 plus 8 is bigger than 15. 3 plus 8 is bigger than 7. So, yes, a triangle can be created. Okay? Are you writing or playing? Lily, put them down. Yes?
1, 7, and 8 equals.
Oh, sorry. Sorry, what did I mean here?
3.
Great. 3. That's 15. You were good to be confused. That was confusing how I wrote that. So, okay, good job. All right. What about the second one? No. Because
5 and 10.
5 plus 10 is not greater than 15. And that's how you can write not greater, a line through it, just like you not equal to, but it's not greater than. If you want to write the words not greater than, feel free. Okay. What about 3? Because? That's right. 2 and 6 is not greater than 9. This is 8. 8 is not greater than 9. Okay? All you have to do is find one thing that doesn't work. And then you're done. Okay? Any questions about that? All right. Let's look at the comparison property of inequality. This is kind of like random little things. But they're talking about inequalities. So that's why they seem random, but they're really not. Okay, let's think about this. It says if A equals B plus C, and C is greater than 0, then A must be greater than B. Does that make sense? Because you're adding something to C, you're adding something to B to get A, then A must be bigger if C is a positive number. Okay? Well, give me some numbers to put in there. Well, so 2 equals 3 equals 2 plus 1. Is 3 bigger than 2? Yes, because this, you have to add, if this is B, this is B, this is A, then this number, to get to this number, you have to add a positive number, then that number must be bigger in the first place. Okay? Maybe, or no. All right. Corollary to the triangle exterior angle theorem. Remember that one? The triangle exterior theorem, what does that say? Do you remember the words? 2 angles.
2 angles.
The exterior angle is the sum of the 2 non-remote interior angles, or the 2 remote. Wow. Okay, so these two go together. They're saying, all right, if 1 is equal to 2 and 3, then which one is bigger, 1 or 2? Same thing as 1 must also be bigger than 3, right? Because if you have to add 2 and 3 to get to 1, 1's going to be bigger than either of those. It's going back to this. Okay? All right, so it's kind of tricky. So you got to look. We're looking for, in this figure, we're looking for exterior angles. We're also noting that we've got some congruent angles because we got these congruent sides. Okay. So, first of all, this is a little bigger here. All right, which angles are the same? 1 and 2. All right, very good. 1 and 2 are the same. Okay. Now, we are comparing 2 and 3. Okay. 2 and 3. Kind of tricky. Don't say, oh, that looks smaller. Because remember, that doesn't always work. Which one do you think is bigger, 2 or 3? Has something to do with an exterior angle, but it's very twisted. Amanda? Because you are right, 2 is bigger.
And what are the angles next to 1? Put that up to 2.
2 is not an exterior angle. Because, okay, so you're talking about this triangle, I'm thinking?
Yeah.
All right. 2 is not an exterior angle because 2 doesn't extend aside. That's where 2 is. A nice thought. Okay. But you're right, 2 is bigger. Okay, exterior angle. All right, take Amanda's exterior angle. Let me get rid of this 2. Whoops, what happened? All right, what is an exterior angle of that triangle? 1. 1 is an exterior angle.
Oh.
Okay, and 1 and 2 are the same. So 1 is bigger than its remote interior, right? Which is 3. So if 1 and 2 are the same, then 2 must be bigger than 3. Sort of. Yeah, you're just kind of swapping it out. It's not really transitive, is it? It's like you're just, okay. So 1 is an exterior angle of ABD. So 1 is bigger than either of the remote interior angles because you have to add those 2 together to get 1. If 1 and 2 are the same, then 2 is also going to be bigger than either 3 or 4. Does that make sense? All right. Now, using that same logic, let's see if you can figure out the reason for why C and 5 are different. When it says compare, it means less than, greater than, or equal to. Okay? A minute. Another thing so I can. So compare means we can put something like that in there. Okay? One of those. Compare C and 5. What do you think, Maggie?
The measured angle C is less than the measured angle.
It is. Can you explain?
Because measured angle 5 is an exterior angle.
Of what triangle?
Triangle DBC.
Sure. You said DBC, right? When we're extending, we don't, let's see, we don't get to, here's 5 like this. Did you extend one side? Because that's what an exterior angle is supposed to do. You got the right idea, but I just the wrong triangle. Which triangle is 5 an exterior angle of? A, B, what? No, and C's not involved. All right, one more time.
ADC.
ADC, there you go. Okay, if you look at ADC, A to D to C, and you extend one side, that's angle 5. Okay? Angle 5 is bigger than angle C because 5 is an exterior angle. C plus something has to be 5, so 5's got to be bigger. Does that make sense to you? Yes? Lucy? That makes sense? Okay. Caitlin? All right. Okay, again, kind of random, but again, it's inequalities. Okay. A lot of times they put these things on the ACT and the PSAT, and then they say, of course, one of your answers is cannot be determined, which I know makes me crazy. So I'm sure it makes you crazy. But there's some determination on sometimes there isn't. Okay. So it says the two sides of a triangle are not congruent. Okay. Pick any two sides that are not congruent. The larger angle lies opposite the longer side. That makes sense, right? Okay, if I put these three different, oops, can't do that one, yellow words, right? Okay, let's see, my yellow is my biggest one, okay? So, they're going to fit together how they're going to fit together. I'm not going to be able to manipulate that. Now, can you tell which angle is bigger? It's the one across from the biggest side. The smallest angle is the one across from the smallest side, because that's how it works, okay? So that's what that says. All right, so we have a little park here, triangular park. All right, in between Hollingsworth Road, Valley Road, and MLK Boulevard. A landscape architect wants to place a bench, here's your bench, right here, at the corner with the largest angle, all right? Which two streets form the corner with the largest angle? Where am I going to put the bench? Where am I going to put it? Am I going to put it here, this corner, or this corner? Largest angle, I'm looking for the largest side. I got 175, I got 105, I got 120. So here's my largest side. So what's my largest angle? Here we get it. Between MLK Boulevard and Valley Road is my bench. Okay? All right. Now we have Zach. Statue of Zach. You look good? All right. You could just look at that one all day, couldn't you? All right. Suppose the landscape architect, I almost said architect, wants to place a statue of Zach at the corner with the second largest angle. Okay, so which two streets would little Zach be on here between? What do you think, Katie?
Hollingsworth Road and
Because the next Hollingsworth and MLK would be right here, because the next biggest side is right here. It's bigger than 105. Very good. So Zach is going, oh look, he's just pointing. He said, I'm going to go there. All right? You guessed.
yeah.
You did not.
Well, it looked bigger.
Okay, yes. And sometimes you can tell that, but there's got to be a reason. Again, largest angle, largest side, across from. That's that word opposite that keeps coming up. Okay, so this is at Hollingsworth and MLK. Okay, second largest side right there. Is anybody finding trouble finding the opposite side and opposite angles? Because it's kind of a big thing. All right. Remember, when we're looking at side, we're pointing. I can't. I mean, I have to be on the side to point to this one and this one. So the one across from is your opposite side. Okay. All right. Okay. Now we're listing. I'm sorry. You want to look at Zach some more, didn't you?
I have a problem with the Valley Road because you said it was across from it. It's not really, but then I thought it's just like the ones that are touching.
Correct. Yes, yes, yes. That's correct. And that's a good point to figure out right now. This road is involved with this corner and this corner, but it's across from the other corner. Okay, good job. All right, let's decide a triangle TUV in order from increasing to decreasing in terms of length. Okay. Well, how can I tell that they all look the same? Well, the angles are pretty close to the same. That's why they all look the same. If I've got 58, 62, what's left to use? 60, right, because I'm 2 less of 60 here. I'm 2 more, so that would be absolutely exactly 60. Okay, increasing to decreasing. Here we go. All right, smallest, increasing to decreasing. So I'm going for the largest, right? All right, largest side is to you because it's across from the 62. Okay, that's a segment. I need to use a segment mark. All right, and then, so I got that one done. Next largest, UV, because that's the next largest side. And then the last side would have to be TV. Okay? Yeah, it's not difficult. It's just sometimes it, like that first one gets kind of twisted. All right, this is my favorite problem, really, because you have to really kind of think through it. It's not as easy as it looks. Okay. Which side is the shortest diagram of all? I'm going to give you a minute to think about it. It's kind of tricky.
Which side is the shortest diagram of all?
Which side is the shortest in the diagram? Shortest of all. There's 2 triangles that you have to pay attention to. Okay. Which one do you think is the shortest of all? Shortest of all. Caitlin says it is QR. What do you think it is? RS. Anybody have another? Or are you all still figuring it out? Yes? Okay, please note that both of those answers are in the same triangle, are they not? Okay, so if one of those answers is right, we should be able to just look at QRS, right? And tell me which one of those, if one of those is the right answer, one of those, both of them can't be right, right? Because they're the same triangle. Which one is shorter, QR or RS? RS. You gave it up?
Yeah. That's weird.
Okay. Well, because it only applies to, it's just like if I created another triangle from here, I can't say, well, this is the smallest angle of all. Let me do it. You're only comparing one triangle at a time, and I'll explain it. But see, that's like saying this, because this is the, I mean, yellow is the biggest one in this smaller triangle, right? Mm-hmm. This is probably the smallest angle of this whole figure. Certainly smaller than this one, right? I could measure them, but so you got to just look at triangles. Okay, so here's what I did. So and then we'll come back. All right. Okay, in the PQR, what is the shortest side? Just look at PQR. What is the shortest side? This was 30. What were these two? 75? Because you knew they were equal, because the isosceles is 2 sides. Okay. So which one's the shortest side? QR. Okay. All right, now go to the QRS. We already talked about that. RS was the shortest side, right? Because this was 40, this was 50. All right, so since Q and R are in the same triangle, RS trumps, right? RS is the shortest overall. Why? because you're just focusing on a triangle. You're saying, all right, on this triangle, you can't look at all and find the smallest angle of all and say, oh, that's the smallest one, that's going to be the opposite side. You got to say, all right, this triangle, small side is this. Okay? Now, look at this triangle, small side is this. So clearly, this one's got to be smaller than this one because we just looked at, that's from 40 and 50. So it's really twisted and weird, but you got to look at all your logic skills. So good job, Maggie, getting that one right. Okay? But watch, it's just a triangle. One triangle. That's all you can compare. Okay, so here is the last thing we're going to do. I feel like it is. Yes. All right. What is the range of possible lengths for the third side? So we're going back to the very beginning where we said, all right, this works, this doesn't work. What is the range of possible lengths for the third side? We get 5 and 8. Okay, so let's figure this out. 5 and 8. We're looking for this side. Let's call x. Okay. What do we know about 5 plus 8 and x?
95 plus 8 is greater.
Good job, Cindy. Okay. What do you know about x plus 8? Very good. What do you know about, what am I missing? X plus 5. Okay, let's solve all those inequalities like from algebra 1. All right, what does this look like if you put x first? 13 is greater than x. What does that mean? X is what? Good job. X is less than 13. Okay, just reading it left to right, right to left, which is not normal, but that's what we should read. Okay, what does this one say? Okay, really? It's a side. I call that duh. Okay? Because we knew that it was a side, it can be, you know it's greater than negative, whatever. Okay, what about this one? X is, okay, so now we gotta combine these. What's your range of possible lengths? It has to be greater than 3 and less than 13. How would you write that in one inequality? Sounds good. Or you could start with the biggest n. 13 is greater than x is greater than 3. Okay? So between 3 and 13, don't say, oh, it's got to be 12. No, you're missing 12.5, you're missing 12.8, you're missing 12.29673. There's a lot of numbers in between 12 and 13. You can't just say, oh, it's got to be 12. Okay? All right, so figure out, there's a pattern there if you want to take a minute to look, but figure out what are the possible lengths for your triangle with the third side of 4 and 7. What it is you're going to say, we're going to do 4 plus 7, and we're going to do 7 minus 4. That's a 7, yes. Really fast. Try that again. All right, so those are the numbers that were in between. So we write it as an equality. 3 is less than x is less than 11. X is between, the side is between 3 and 11. So it could be 3.2 and 10.58. Yes?
Are the inequalities, does it have to go from like 3 to 11 or
No.
as long as you're the symbols?
Yes, these should be facing the same way. It's a good question. When you write a combined inequality, your inequalities have to face the same way, otherwise it doesn't make sense. Oh, sorry. Oh, we're so good. 11, how about this? Yes, they have to switch the same way. I typically do least to greatest, but it doesn't have to be that way. Okay, so I think Maggie just kind of discovered her theorem here. Notice the third side, so how would you write that theorem? For everybody that's gone, let's take a minute to write our own theorem here. What for you? In a triangle, the third side, then maybe, if I have it. Lily.
That's kind of long.
Okay.
In a triangle, the third side's inequality is determined by adding the two numbers to find the upper bound and subtracting the smaller number from the larger number to find the lower bound.
Sounds really good to me. Can we get it more compacted? Lauren?
In a triangle, the third side has a range of the smaller side subtracted from the larger side, so the sum of the two given sides.
Okay, that's basically saying the same thing. That's good.
In a triangle, the third side has to be equal to the range of the sum and difference.
That's beautiful. Get the sum, get the difference. Okay, so let's do it. I like it. It's compact. All right, say it again, Maggie.
In a triangle, the third side has to be equal to the range of the sum and difference.
Maybe I started you wrong, because there seems to be extra words in there. But I like the sum and the difference of the other two sides. That's pretty compact, because you got two, and you're not going to worry about being negative. So the third side, how about the range of the third side? That would be even. In a triangle, the range of the third side has to be this, the sum and difference of the other two sides. I like that. It's a little bit more compact, but basically, you're going to remember how you're going to remember it. If you need more words to remember it, then go for it, okay? But we talked about, what did you notice about the lower bound? That was the difference. This is what you get here of the two sides. That's your lower bound. And this, the upper bound, is the sum of the two sides.
It just makes me about the bigger than the thirds.
Yeah, that's, I wouldn't worry about that. Yeah, that's kind of just like writing an inequality properly. I wouldn't worry about that. Good question, though. Okay. Let's be doing. Oh, why practice? It's really good. 5.6. Practice. I sent it to you. Everybody check if they got it. All right, go ahead and shut those down.